In this section we are going to show you the definition and updates of the MBoM from the EBOM shown previously. However, before I do that, let me explain a little bit about the two. On the left you see the EBOM is owned by Design Engineering and is typically structured in a way that suits them. This could be by the architecture, system or functional group. This EBOM will be read-only to manufacturing. You won't want manufacturing changing the design intent created in Design Engineering. On the right you see the MBoM. This is made up using the components from the EBOM but is typically broken down into the way the product would be produced. It may also include consumables used during manufacturing processes or jigs that are required. The MBoM is typically what an ERP system needs to ensure that all the components or sub-assemblies are in place to produce the product. The MBoM will be owned by manufacturing so they can structure the information the way they want. The demonstration itself will first review the current MBoM. We will see that the components making up the MBoM are the same ones used in the EBOM but structured to suit manufacturing purposes. We will also see, like the EBOM, this is an 150% MBoM and can be filtered down to 100%. We will then show you how the MBoM is generated from the EBOM and how updates in the EBOM are considered. We are currently logged into Teamcenter as a user who is from Manufacturing Engineering. The first thing we will do is look at the current MBoM like we did with the EBOM earlier. This time we will search for the MBoM. Teamcenter returns all the results relating to the search and we use filters to get to the coffee machine MBoM and open it up. Like with the EBOM, we can expand the structure to look at the details, but this time we see the structure is defined by the stations on the line we intend the components to be assembled. We can also look at the MBoM in 3D, and again we can see the strange graphics because multiple components are in the same place. This is because we are seeing the current 150% MBoM. We can see what components are used at each station by turning assemblies on and off in the structure. We can also apply the same variant configurations to the MBoM to filter it down to a 100% structure. Let's look at the same configuration we showed earlier in the EBOM. We can now select the electronics display in the graphics to highlight it in the structure. We can again perform a were used on the display to see the parent assemblies and related information. This is the same electronics display assembly we reviewed in the EBOM, so we see the same information, the multiple EBOMs it's used in, the MBoM and the bill of process. Now let's look at how we define the MBoM from the EBOM. We start by opening a package that holds the EBOM, MBoM, bill of process and plant details from my favourites. From here we will look at the EBOM and the MBoM side by side. This view shows the consumption status of the EBOM components in the MBoM with indicators against the items. We can also view both the EBOM and MBoM in 3D like previously shown. We can expand the structures and highlight components. Now we pick on the status icon against a selected component, we can see its location in the MBoM. Looking further at the structure, we can now highlight the changes to the EBOM that have resulted from the change to introduce our new smart control unit. First, in orange, we see the mismatch between the new Mark II power control and the current consumed Mark I power control used in the MBoM. What we do to rectify this is remove the old power control board from the MBoM, select the new board in the EBOM and then assign it to the required position in the MBoM. This now gives us a blue tick in the EBOM to show the mismatch has been resolved. We now need to resolve the consumption of the new smart control unit items. However, we will first look at these items and see they have a variant condition applied to them. Basically, they are only applicable if the Smart App feature is selected. To consume these in the MBoM, we do the same as previously. Select the items, then assign them to where we want them in the MBoM. You can see the variant conditions also transfer over, allowing us to filter the MBoM from 150% to 100% as shown previously. Now let's look at the benefits of managing the MBoM in Teamcenter. First, because it's integrated with the design process, we can perform the shift left approach and work concurrently to develop the MBoM. You also get the other benefits of using PLM in looking at the relationship between items to aid decisions processes and impact analysis of potential changes. The rich visualization content we get in Teamcenter can also be used to aid us in defining the MBoM, reducing the number of errors. Because we are starting the MBoM process earlier, we increase the quality of the BOM, first time out reducing errors and allowing us to report on the likes of cost to make impactful decisions. Finally, the MBoM is the basis for creating our bill of process, which we will show you later.